This video is brought to you by Squarespace. From websites and online stories to marketing tools and analytics, Squarespace is the all-in-one platform to build beautiful online presences and run your business. I am taking capture card reviews where no man has gone before. So this is going to be an interesting project. I have tested over 20 capture cards, all of the ones that I had access to over the past couple months and in my possession, and I am documenting a lot of things about them. Their input latency from your actual input signal to OBS into the native applications, the available decode mode supports, the available supported resolutions, frame rates, things like that, whether or not there's scaler built into the hardware or driver, and things like that. So this is a lot of data and a project that I will be updating over the course of, well, the foreseeable future. Multiple years, most likely. So I will point you to the actual OBS project resource page I have created for this project, as that will be where you can find updated information if you're watching this video later on, or if you feel like a capture card is missing from this list and you want to check and see if it's there. It will be potentially on there if I have access to it, and we'll talk about some ways to get your capture card featured as well in the future. But the big thing that I started this project focusing on was latency, because I have found that there is a deficiency in capture card reviews, one of my own doing, where there isn't enough technical detail documented about these things. And honestly, the companies selling them don't document a whole lot either in terms of more advanced stuff. They expect them to be used by people who either figure it out themselves, like me, or by people who generally don't care, and that's somewhat valid. This is kind of a super niche deep dive, but I wanted to do my part to help document this stuff. Since I have so much access to capture cards and so much experience with them, I want to do my part to document these kinds of things and make them available in a consistent manner. And I've been really bad in my own capture card reviews about not like documenting stuff on a grander scale from review to review. I just kind of test them one at a time and let them go. So I've gone back through all of the capture cards that I have access to test this kind of stuff. Granted, we are only talking about HDMI capture cards for now, because analog testing gets really complicated since everything's HDMI based now, but that's what we're working with, is latency, decode mode support, and then resolution modes and things like that. So what I have done is I have taken a monitor latency testing tool. It basically just hits light from your monitor and you check and see how much input latency the monitor has. There is, of course, 3 different points you can check latency at. That's the top of the monitor, the middle of the monitor, and the bottom of the monitor. Now, the lowest number that the bottom of the monitor can read is 16.7 milliseconds. This is a 1080p 60 tester, because that is one full frame, which is displayed, line by line from top to bottom of the monitor. So one full frame would be 16.7 milliseconds by the time it gets to the bottom of the monitor. And so what I've done is I've done latency testing on all of the monitors that I'm using to test, and then I test the input running through the capture card, and then I subtract the monitor's latency from that to get the capture card's latency in the applicable software. I also went through and tested latency to make sure that there were not any standouts of capture cards whose pass-through is not real-time, and I did not encounter any of these. So none of the capture cards that I tested were not real-time, and I will note in the future if I encounter any that don't have real-time pass-through, but so far everything has been exactly, 100% real-time, as if you were plugging into the monitor. So that is good to note. Otherwise, let's jump into the data. And again, I will point you to this OBS project resource page, because that's going to have the most accurate, up-to-date information as I update this over time. But I'll do my best to kind of display this in charts and graphs here. And so what I have done is, first, my main focus was focusing on OBS Studio and what the latency to OBS's preview is. And I have confirmed with devs for the most part that OBS's preview is, the latency to that would be about as close as I can approximate to the actual, to your video encode or live stream latency as well. And we'll talk about some limitations in my testing scenarios and things like that towards the end of the video. I sorted by, fastest to slowest, and nothing really stood out too crazy. If you look at what the fastest capture cards are, which would be the lowest latency, for the most part, it's the ones you would expect, the higher end, newer ones, the Evermedia Live Gamer 4K, the Magewell PCIe capture card, and then you have the Gen 1 Cam Link, which is lower latency than the Gen 2 Cam Link. So I wasn't crazy in my original review in my suspicion that it was slower than the Gen 1 Cam Link. So that confirmed some suspicions of mine. And then this generic one I haven't even reviewed yet from Moco's was actually really low latency. But for the most part, there isn't actually a significant delta between most of the slowest and fastest capture cards. However, there are two that stand out as abundantly obvious and ones that I have spoken against for a very long time if you're using them in OBS, and that is the original Elgato Game Capture HD and the HD60, because both of these route through onboard video compressors that are meant to just dump the footage to Elgato software to your computer and not be looped back into OBS and things like that, and so they have very slow latency. HD60s only rang up as about 101 milliseconds in OBS itself, which was quite impressive for it. I've never seen that specific card perform that fast, and even in Elgato's game capture software, it was 690 milliseconds. So clearly a significant difference between OBS and Elgato game capture for that specific card. But then you have the original Game Capture HD, which even in OBS was, in my testing, 575 milliseconds of added latency. And this can actually scale from a few hundred milliseconds all the way up to 3 seconds or so, depending on your use case, which is why I've always said these USB 2.0 cards are not great for implementing into OBS or live streams, because their latency is so inconsistent and so wild that you're going to have a lot of hard time syncing up audio or face cams or anything like that. Now, I also tested where it was applicable if the capture card had it or I was capable of installing it, the native applications created by, the manufacturers of the capture cards, what their latency was as well. So we're talking Elgato's 4K capture utility and game capture software, AverMedia's RE Central, Pot Player for a couple of the generic capture cards, UX Player was one, Magewell's Capture Express, Media Express for Blackmagic cards, things like that. And for the most part, there wasn't anything too significant or weird. Blackmagic Media Express, I couldn't figure out how to full screen, so my results are not super accurate there. But what I found really interesting is that Elgato's 4K capture utility app has significantly, ridiculously slow input latency compared to even their game capture app, and especially compared to OBS Studio, which is really weird. We're talking the HD60S, the Elgato's, last USB 3 capture card before they started moving to 4K stuff. In Elgato's 4K capture utility app, that had 149 milliseconds of input latency, but in their game capture app, it was only 53 milliseconds. And in OBS, it was only 57 milliseconds. And then if we look at the Camlink 4K in Elgato's 4K capture utility, it had 166 milliseconds of input latency, which was more than double what it had in OBS. But then I discovered something even more interesting, and why I think the 4K capture utility is actually, it has deliberate added render latency in order to keep performance up or to catch potential hiccups, or perhaps this is caused by the flashback recording module, and I need to test that again and find out if disabling that improves it at all, is that running the Elgato 4K 60 Pro into 4K capture utility netted me about 202 milliseconds of input latency. And this was consistent because I ended up, when I discovered this thing, going back and forth with it a few times. However, in OBS Studio, directly connecting to the capture card, 88 milliseconds of input latency. But 4K capture utility has another feature called Streamlink, which is an NDI feed, a network transfer protocol of basically streaming your footage over the network as if your network is the capture card. If you run your capture card into Elgato's 4K capture utility and then send that to OBS via the Streamlink, that was faster than just running it directly into Elgato's 4K capture utility, despite the fact that you're going capture card, Elgato, Streamlink, OBS. That was faster than just the 4K capture utility on its own. It was still slower than OBS just directly, but that was really bizarre. So I do think there is some deliberate slowdown on 4K capture utility side, and I will update the numbers or add a little bit if I discover that disabling flashback recording fixes that. I didn't think about it or have time before shooting this video. I just kind of thought of that here, and this is take 2 of the video. So there's always room for error with these tests. Another thing I found interesting is one of the fastest capture methods and things that I tested was this BirdDog Studio NDI encoder. This is an NDI encoder and decoder box. And again, NDI is a network transfer protocol. You send your video signal into this and it broadcasts it over the network to be decoded by NewTek TriCaster boxes or OBS Studio, things like that. that only had about 68 milliseconds of input latency within OBS from the network connection. And granted, that would change over time and depends on your network and yada yada, but that was faster than some capture cards being directly connected, and I found that really interesting. Something else I wanted to note on the Elgato side was the HD60 Pro. They've always advertised that card as having instant game view, which meant that it had a really low latency preview in their software for potentially playing the game from, or just being easier to sync up your game sound with your mic audio and things like that. And people regularly made fun of that as being like a gimmick or something ridiculous, and people make fun of low latency claims in general. But I did discover that running that capture card into the game capture app, it pops up the instant game view thing. That was actually faster than OBS Studio directly, and I think that may be one of the rare situations where that was the case. But it was actually about 5 milliseconds on average faster than OBS's direct preview by running it with instant game view into the game capture software. And that was about 63 milliseconds of input latency for the HD60 Pro. Meanwhile, that same capture card ran into Elgato's 4K capture utility was 178 milliseconds of input latency. So a little bit weird there. And then the fastest native app that I tested was, although it was inconsistent from card to card, but it was AverMedia's RE Central software. With a lot of them, we're talking 62 to 65 milliseconds. Although with a lot of them, like I'd hold up my latency checker for quite a few seconds, or usually a couple minutes. I mean, for each test, and I'd go back, and it would regularly keep increasing. And so the way I was actually measuring this was, because some capture cards, they'd be like 75 milliseconds for a few seconds, and then jump up to 95 milliseconds for a few seconds, and then back down. And so I would take the higher of those kinds of options, but I'd aim for whatever was the most consistent result. And then for some examples like AverMedia stuff, for whatever reason, it just kept increasing over time. So I went for multiple test runs of what was the most consistent and then rounded up based on decimal places, because there's a little bit of margin of error in there anyway. Before we get to the second phase of this testing and data documentation, yada yada, I did want to tell you about our sponsor, Squarespace. Squarespace empowers millions of dreamers, makers, and doers by providing them with the tools that they need to bring their creative ideas to life. On Squarespace's dynamic all-in-one platforms, customers can claim a domain, build a website, sell online, and market a brand. Their suite of products combines cutting-edge design and world-class engineering, making it easier than ever to establish your own online presence. So head on over to squarespace.com for a free trial, and when you're ready to actually launch your website, squarespace.com/EposVox to save 10% off your first website or domain purchase. Go check them out. All right, I wanted to just briefly touch on, again, you can dig through all the data yourself in the actual OBS project resource page, but I did want to detail a little bit of the decode mode support. So I've listed, the max input and pass-through resolution, frame rate, things like that, support for each capture card on the HDMI feed, as well as what connection type there are, if they support ultra-wides, HDR modes. But the decode modes are basically the color formats, the kind of color compression that the capture cards support. And there's a few different options. There's actually some you may have never heard of, some that I wasn't sure of until I started really digging into this. The most common one is YUY2, which is a 422 color compression. The complete uncompressed color space would be 444. 422 takes that third color tier and compresses it a little bit, and the second one compresses it a little bit. And then there's 420, which compresses that third one even more. I will post links to some explanations in the description because this is not the video for that. But the most common one is YUY2, which is 422, and then there's UYVY, which is basically the same as YUY2. Those are the most common, and that is going to be uncompressed, not pre-compressed on the capture card, access at 422 color compression. Keep in mind, bandwidth compression and like data rate compression is different than color compression. And then you have some capture cards that support MJPEG, and I've talked about this in a couple of capture card reviews. MJPEG means that basically your capture card is doing it's basically pre-compressing your video feed. So a lot of webcams only have this as well. Everything's pre-compressed to a format, motion JPEG. It's literally a series of JPEG images on the capture card itself and then sent to your processor. And the problem with that is not only is it lower quality because you're limited to a pre-compressed format, but that means that your CPU has to do more work because your processor has to decode that. Once the capture card is sent to OBS, it has to decode that and uncompress it and then recompress it and encode it with the rest of your video feed within OBS, which is a lot of extra work adds more latency, and again, it's a little bit lower quality, even though a lot of MJPEG stuff is based on 444 color space. YUY2 is an uncompressed feed, which means it uses a lot more bandwidth over USB or PCIe, but it means it's lower latency and that your processor has to do less work because it doesn't have to do the uncompressed stage or decompression stage. It only has to take that raw feed and then compress it in your final encode in OBS. Now, there are a few capture cards that support direct 444 RGB. These are mainly Magewell and Blackmagic, and then AJA is another industry brand that I don't actually have tested here at the moment. But those capture cards all support completely uncompressed 444 RGB and are ridiculous and awesome. The only USB capture cards that support 444 RGB are, again, Magewell, and then the Live Gamer Ultra can do it at 1080p, which is pretty cool. And then all of the Elgato capture cards and the Elgato drivers at the moment are listing RGB support, but I have confirmed with my Elgato contacts that that is not true RGB because their capture cards pretty much operate exclusively in the 420 color space in general, which is why their preferred decode mode is NV12, which is a 420 and decode mode. So they will list RGB, but you either get a green screen, no feed, or it will be washed out or a little finicky because basically the card's driver is converting the 420 color space back up to RGB, and then OBS is having to decode that and recompress it again, and it's a mess. Don't mess with that. But if you want full 444 RGB uncompressed signal, which will give you the most accurate and best scaling possibilities and color representation and video feed overall, but comes at a much higher price and much more bandwidth, you basically got Magewell, AJA in some cases, and then Blackmagic design capture cards are pretty much your only options. But again, that Live Gamer Ultra is a USB option for 1080p 60 that kicks a little butt. I also went through and noted whether or not a scaler was an option for the capture cards. That's pretty much denoted by if you add it as a video capture device in OBS, under custom resolution settings, if you can choose more than the default input resolution of the capture card, then there is a scaler either on the driver or on hardware. As far as I know, only Magewell, Blackmagic, and maybe AJA have actual hardware scalers because they have full FPGA chips on their capture cards, which have a full video engine which can de-interlace and scale and do all sorts of stuff. And so that's all done on hardware, which will be the most efficient way of doing it. And then the other capture cards that do have scalers are pretty much all done on drivers, which is still, done in software on your computer, but there's not really going to be a major performance difference between doing it in driver versus doing it on OBS's canvas in OBS's settings. So yeah, this video was pretty long and had a lot of information packed into it, but I am trying to take capture card reviews to the next level. I want people to have the most information they can possibly have to work with when choosing a capture device or recommending them to others, and it's information that I want to be able to, it's information that I've gone looking for and haven't been able to find documented anywhere, so I want to do my part, contributing that back into documentation land and making sure that other people have access to it. So make sure you check out that OBS project resource page linked in the description. I will be updating that as I test more capture cards because I'm always testing more capture cards. And if I discover more specific driver related information, I will update that document as well. I also wanted to mention some limitations of my testing in that I can only get so accurate because I am testing preview-based latency, and this is going to be best case scenario. I'm working with an Intel i9-7980XE, a very high-end workstation class motherboard, high-end USB chipsets, high-end PCIe slots running direct to the CPU. I can't reliably recreate worst case scenario situations where you're going to have higher or more inconsistent latency. That's just not something I can scientifically or reliably recreate over and over for each capture card. So these are best case scenario numbers. And this is also a situation where it's going to be a little bit inconsistent. There are numbers that will scale, it'll change over time. If you have more added to your OBS scenes, such as WebM overlays, a webcam, things like that, your render time for OBS is going to increase because there's more for OBS to do. So there's a lot involved there which can affect this. This is meant to be just a direct, as close to accurate as I can get representation of the capture cards themselves performance. And again, I'm only one person testing on one config. There's limitations with that. And then the big limitation is, of course, this document will only ever contain capture cards that I can test myself because that's the only way to get this kind of real information. And I only have access to so many capture cards. So if you are someone with capture cards lying around for some reason, old hardware, things like that, or you're a capture card company looking to have yours added to the list and tested, you can send them to me. I do have my P.O. box linked in the description below, or you can reach out to me. If you do just send it blindly, make sure you include return address like on a note and why you're sending it and that you want it back included in the packaging, or else I can't know to send it back to you. But yeah, I am open to taking submissions to further improve my documentation, because ideally I want to cover all of the capture cards, but I can't just go buy them all and I only have access to so many myself. But hopefully this helps. Let me know what you think in the comment section down below. Hit the like button if you enjoyed. Go check out our sponsor Squarespace at squarespace.com/EposVox. Subscribe for more tech education. Check out all of my capture card reviews. I have reviewed pretty much all of these in the description down below, and I'll see you in the next one.